Andrew. I'm the founder of AlarmSystemsTraining.com. Obviously, you've clicked here because you're a student. That means you're either new to the alarm business, or maybe you got no interest in the alarm business at all. You just want to learn some basic electronics. And we have several videos that basically go into that. We're going to just quickly give you a taste of what that's all about. But if you're a student getting into basic electronics, low voltage electronics, number one, get yourself a decent meter. Meters are in direct proportion to what you spend on it. Don't think you're going to get a good meter if you're going to go out and buy, pay $9.95 at the local Ace Hardware store. That's not going to work. To get a decent meter, you want it to be able to take at least 12 amps of current. And obviously we'll get into that in the videos. And if you get a decent meter, 10 amps of current, you're going to spend at least $80, $90. And you can spend more, but you can find one at $79.95. That's a decent meter. We're low voltage electronics and low voltage resistance and so forth. You need a good digital meter so that you get numbers that you can really deal with. So number one, highly recommend a decent meter. If you're going to be a tech, got to have a meter. One of the things that we go over, in the technical videos is electron flow. We take it right down to the basics. How electrons move through copper wire and through anything, and how electrons and protons affect each other, and how do we get from electrons moving to a 12-volt battery, and so forth. And just about all of the low voltage systems, they're going to be anywhere from 4 volts to 12 volts, maybe 24. Telephone systems have 48 to 52 volts, on the outside connecting block, but that's about as high as you'll ever go. Most of it's going to be 12 volts to 24 volts, DC. So batteries, current flow in and out of the batteries, the power supply is very intricate for you to understand how that works. Give you an example. The refrigerator in your kitchen, it's supposed to run on 117 to 122 volts AC. May draw 12 amps while it's running. Well, maybe in the middle of summer with everybody pulling electricity, a little bit of a brownout, the electricity might go down to 98 volts, 102 volts. Well, your refrigerator probably will survive. It'll continue to work, that motor will go, the compressor will work, you won't really have a problem. But in low voltage DC, you don't have that luxury. If your system needs 12 volts and this piece of equipment that you have on it wants 12 volts, you can't go down to 7, you can't go down to 8, it's not going to work. So what happens when your battery's weak and it's putting a load on the system and so forth, and it's pulling the voltage down and the current's not available? All these things we review in the technical series of tapes, and you'll understand why that's so important. Proper joining and splicing. Most people don't give that a second thought. They take wire nuts, they take little beanies and crimp them. They may solder. If they solder, that's great, but nobody uses a soldering gun anymore. It's kind of old hat. But if you don't do a joint correctly, it's going to corrode. The corrosion is going to build resistance. The resistance is going to draw more current. It's going to drop the voltage. You're going to have problems. And again, our other technical series goes into the whys and wherefores. But just understand that that's something to pay attention to. That whatever you're building, whatever systems you're putting together, you can't cut corners on splicing. You got to do it right. Keep the oxygen off the joint so it doesn't corrode. And we go through that. Grounding and inductance. There's a big argument out there. Should you ground or shouldn't you ground? Well, understand that the electrical code in the country, they think of life safety. So, your AC circuit in your house has to be grounded because if something goes wrong, they don't want you to die. They want it to blow a breaker, and then it kills the power and all you did was get a shock. But with low voltage DC systems, the microprocessor running on 4 volts, drawing 20 milliamps, it's so sensitive that if you start grounding that equipment, well, you're telling the surge, it's okay to hit me because I'll give you a path to ground. So there is a school of thought out there that says if you're not grounded, why would the surge hit you? Because it's looking to bleed to ground. So I'm not telling you one way or the other. Every system's different, every circumstance is different. But just keep this in the back of your head. Sometimes a no ground scenario is better than a bad ground scenario. And the technical series goes through that and helps you to appreciate that. But this inductance, sometimes people have heard that word, but they really don't understand what that is. how one circuit that's got nothing to do with your system can induce a voltage into your system and now make the brains go squirrely. So really understanding inductance helps you to understand how to properly wire and how to stay away from other people's systems. Because as soon as you start running parallel with somebody else's system, they can induce a voltage into your system, give you all kinds of grief. So really pay attention to the inductance training tape, because once you understand that, you're going to be heads and shoulders above your competition or your students as your ability to be able to discuss some of these things. Some of the courses that are in the student, there's 3 do's and don'ts of proper wiring, proper splicing, how to run wire in and out of your project cabinet, the proper way of doing that. We got 3 basic electronic courses. So we start off on static electricity and how electrons are formed, all the way up to how to measure it, how to deal with it, how to prepare for it. Batteries and power supplies, no matter what kind of system or project you want to put together, is going to need a power supply. How do you do your arithmetic to figure out how big the power supply needs to be and how strong the battery has to be to back up in case the AC power goes out? So we go through all of that. And then we go on to understanding inductance, the lightning and surge protection, and proper grounding, and surging. So there's quite a few tapes in the student module, which I believe you'll enjoy, you'll learn from, and perhaps even when you're done with that, you'll then want the professional series that fills in all the other details. So we appreciate your time, we certainly appreciate your business, and we look forward to hearing from you and seeing you on other occasions.